Hello, I'm Robert, voluntary fact checker if you're scared. And this is to help you understand the Sentry table, and which most people, this is my non-techy interface, and this is what, if I just go and look across the page, then let's find the right page. This is what you see if you go and visit this page. So if you go and visit I haven't found anyone who understands this table properly when they see it without me explaining it to them. If you're a mathematician or astronomer, you probably would. So you go and look at this, you look down, you see a whole range of numbers. And the only number that you need to know about is this one, the last column. So when that says 0, it means it's no hazard. When it's blank, it means it's far future. And then if it goes to 1, 2, 3, 1 is normal, and then higher than that, you at level 2, 3, 4, you start getting of interest to astronomers, and eventually of interest to the general public. And no asteroid has ever got as high as of interest to the public in this list. So there's a story running right now that is scaring lots of people, which leads them to believe that there's a big warning about a planet, it's a so-called planet killer in inverted commas, complete hyperbole up to nonsense. And so if you go and check here, you can see there isn't any warning. But so I actually wrote and suggested them that they replace this 0 by no hazard, but I don't think they understand the need for doing that. That's what it means. 0 means the word no hazard. And but they have, but the so to find out what it means, you have to go down here, and when you visit the page, you click here and you see show legend. So that's what you see. When you first visit the page, that's what you see. In order to find out what this means, you first have to click show legend. Then you read this, and it's really quite techy written. It's not that easy for people to kind of navigate the scientific knowledge, the scientific way of saying things, and and then having got through all that, you've got to look at that and say, well, the colour of the table gives a rough interpretation of the severity of the threat. You've got to realise, well, okay, it's the colour that matters, and then you read a little bit further, and then white or grey colours indicate a Torino scale of 0, but what's a Torino scale? And all other colours represent the respective Torino scale. What's a Torino scale? And most people will just click away at that point because it's just too techy. And then if you do persist and click through to Torino scale, then that's when you eventually find out what it means. So which one of these is the Torino scale? That one. No. That one. So you click through to Torino impact scale, and there you see that 0 means no hazard, 1 means normal, 2, 3 and 4 means meriting attention of astronomers, and if it's white, green or yellow, that's what those numbers mean. So if I go back to that page, then that is what that number means. It means it's no hazard. And then they don't explain there, but that when there's no number, that means it's far future. So now, if you go back to my non-techy interface, and all I've done, and then yes, the other thing you need to know is that it's ordered with the highest risk first, if any. So that means there's nothing here that is higher than no hazard in the table. And you can click to order it by Torino scale. You can order it by the estimate diameter, or you can click and order it by the Torino scale, and that's got the highest Torino scale first, which is the default when you get to this page. And then the blue ones are very small ones, and as you can see, they're all listed as no hazard as well, with 0. So my page here is the front end to the same database, and it interrogates the database, and it looks and it searches, and it finds the highest number, and whatever that number is, it displays that at the top here. And so it says 0, no hazard. And then it's got these ones that are far future. It writes that it's far future. This one is for the year towards the end of the 22nd century. This is for the 29th century. And it's only very large ones that are kept there. The small ones are just removed from the list, but larger ones, if they discover that they can't hit this century, then they may keep them in for the far future. So the two left in the future in the list for the far future. And so that's it. Gives you down to the dates that says there's no hazard, or it says what neutrino scale is. The other thing you can do, you can click here and search for object. So I have entered the object 2022 AP7. So if you look at the story, then somewhere in the story it will give the name of the object. So this one everyone is scared of is a planet killer. Then if you enter its name in there, 2022 AP7, then you see that it was removed from the impact list on the 2nd of February, year, month, day. That's the order, and then the time, hour, minute, second. Smaller unit and last, larger unit first. That's the order there. And then you can click through to the removed objects page, which is the other, this one I think. Let's see if that's, no, that one. You click through to the removed objects page, and if you enter, so I'll just remove that. See, those are all the objects that have been removed, 3,000. So then if you enter the name of the one that you're of interest in, then it tells you, you can find it and it says it was removed. And it's the exact same numbers. I'm using the same database, so naturally I show the same numbers. So that's what it shows there. 2022 was moved from the risk list from 20 on that, then I explain that in words, what that means. And so this is a non-techy interface to the exact same data and shows you exact same numbers. But it leaves out some of the things that are very techy that are only of interest to experts and geeks. And then there are a few other links here that could interest you. If you click on Show Observations, then that takes you to the Minor Planets Center. See if I can find that page, Minor Planets Center. And this shows you all the observations. So I'm looking at 2022 AP6, with AP7, which is the one that we're of interest. And so it was first observed, it tells you at the top, it was first observed on the 1st of January, and at the Cerro Tololo D cam, that's dark energy camera. And then it finds pre-discovery images where, if you go down, look here, lots of techy details. And this was 2017, they discovered a bit later. So this is quite common, that they discovered a very faint, when you find an asteroid, they then search back in other images that people have taken in many telescopes. For instance, this is the Mount Lemmon Sky Survey, which was conducted in 2017, and amongst the very faint stars that it detected, then one of them was actually this asteroid, and it wasn't a star. But they didn't know that at the time. And there was another one here, and so that was recorded in a slightly different position. So conceivably, if they managed to collate together that one and that one, they might have wondered if it was an asteroid, but there's loads and loads of photographs to look at, and they didn't trigger it was an asteroid until it was spotted with this one. And so then it was observed on January the 13th, and they kept on observing it, and through to, that's all on January. The first one is the date, second is the day, and then this is the time of the day, which is decimal time, so 24 hours is equivalent to 1 there. And then you go on down, and then there was a big gap, and that's not surprising, either behind the sun or too far away from the sun to observe. So then they observed it again on the 10th of October and 10th of, 10th of October, and then again on the 29th of October, then someone observed it. So probably needed a very big camera to see it, and they just only sometimes look in that direction with the very biggest cameras. So that's there. You can go to that from that page, the minor observations. The other place you can go is the small object browser page. There are various other things you can go, but those two. And so if I go and look at there, I think that's, is it that one? Yes, there we are. Then we can see its orbit. And I've set this to where it was. If I look at that, can I turn it around a bit? Yes, I can. So this was the day. You can set the date of this. This shows its orbit. This is where it was when it was discovered. You can set that there. So I've set that the 13th of January, the date when it was discovered. And as you can see, it was that's the Earth, and that's where it was, and it's quite close to the Sun. It's in what they call astronomical twilight, where so that means that that as the Sun was setting, then it would set not long after, sometime after the Sun, but still in astronomical twilight. At that point, it'd be quite dark with the first stars coming out, but to a telescope, you wouldn't, be good clear conditions. You're not going to be able to see the fainter stars. Sorry, I don't know how that happened. So this is a special telescope that's got that's sensitive in the red. I was able to discover this when it was very far away, but in the astronomical twilight, and yet it observed it. And as you can see, it's in an orbit that gets nearly out to Jupiter, and so it's quite surprising they didn't discover it before. And one theory in the most recent paper that's just been published that all these fuss was about, and in that paper they say that maybe it's a comet, an old comet that is turning slowly into a kind of wobbly asteroid because it's losing its ice. So then it might be that that would mean it might be rather smaller than the estimates, because it would be brightening because it's near the Sun, and some of the ice is evaporating into a bit of a coma, cloud around it, or maybe a slight tail. And it's just too small to pick out those details to know if it's a comet or an asteroid. And then if you go and look at it, this is 2022 AP7. Now if I can tilt it, then you can see these lines like that. This shows how far it is from Earth's orbit. That's the plane of Earth's orbit. If you look very closely at it, then you can see that it passes quite a bit above Earth. So these are all things, you can just follow what I'm doing here. You can do the same yourself and check for yourself. So it might seem as if it's going quite close to Earth. So remember, this is where it's closest to Earth, just there, where the line goes down to Earth, to actual Earth's orbit. That's really quite a big distance. The closest to Earth's orbit, not close to Earth. And so if you compare that with the distance from the Sun, which is 93 million miles, you can see that's quite a short distance, quite a long distance. And it's actually about 7 million kilometers. You would have, if you were traveling to give an idea of how far that is, if you were traveling in a 747, then it would take you nearly a year traveling non-stop at 900 kilometers an hour to travel the same distance around the Earth. And you'd have to go around the Earth over 120 times to go that distance. So that is very, very far from Earth. But it counts as a potentially hazardous object, means that it is in an orbit that is within a certain distance of Earth's orbit. It doesn't mean it's going to hit Earth. It's a very confusing, techy term for non-astronomers. A PHA, or potentially hazardous object, just means that it's so there's some objects that count as potentially hazardous that are actually orbiting a third ahead or behind Earth, and they're in a kind of stable zone there, and they're never going to hit Earth, but they're close to Earth's orbit, and so they still count as a PHA. And it's another one that's a kind of sort of like it's like a very distant moon of Earth, and that again, it's in it's a kind of balance between Earth's orbit and Sun's orbit that makes it like the moon but much more distant, and that also counts the PHA because it's close to Earth's orbit. And so this idea of a PHA doesn't mean it's actually going to hit Earth, any ever indeed. And then if you look over a long period of time, they'll get deflected by the planets as they fly. This isn't a stable orbit, so over a very long period of time, it's not going to stay in this orbit indefinitely. It can't. And in this case, it actually, so Mars at this point Mars has got an orbit that's tilted quite a bit compared to Earth's. And if you look very closely at this, it's quite a lot closer to Mars's orbit than it is to Earth. It almost looks as if it's crossing it. It's very, very close to Mars's orbit. Possibly, I mean, one wonders if it got into this orbit by flying past Mars. And so it might be that eventually it's going to hit Mars. But this is just me, just eyeballing this. So but if you look at it, eventually these objects, near Earth objects, then they're going to hit either eventually they're likely to hit they won't like to hit Jupiter because it's a very big target, and this one comes close to Jupiter's orbit, and over a period of time Jupiter might perturb it enough so it hits Jupiter. Then the other very likely place to end up is that after lots and lots of flybys, so it's not easy to get close to the Sun because you've got to lose a lot of velocity in order to, you've got to do like a flyby of Jupiter, a flyby of other planets, and it's very hard. You've got to lose a lot of your potential energy. You've got to actually in a way gain velocity to get close to the Sun. You've got to turn your orbit down and travel very fast towards the Sun to have any chance of hitting it. And so you've got to stop the orbit that way and make it go fast that way, and then you can hit the Sun. So it's not easy to hit the Sun, but over many orbits, as it flies by Earth, Mars, Venus, maybe Mercury, and it flies past Jupiter, which can do a big change quite quickly, it could eventually hit the Sun. And that is one of the most common. So most of these asteroids, they either hit Jupiter, or they hit the Sun, or they fly past Jupiter, and just like our satellites are sometimes boosted by Jupiter to go flying past and go to interplanetary space, the same can happen to an asteroid. And so it can end up leaving the solar system. Those are the most common. Then a few percent will hit one of these. So that's the most likely thing that's going to happen to this asteroid long term. Not that it's going to hit Earth, but it's going to most likely hit the Sun or Jupiter, or be ejected. And then there's a small few percent chance it hits one of the planets. If it's going to hit anywhere in the near future, actually Mars looks more likely than Earth, but just eyeballing it. And then it can also fly past Jupiter and hit Saturn or one of the other planets further out, and that is quite a low probability, but it does happen occasionally for near Earth objects. So you can, once you've got a little bit of background, you can go and look at this diagram and get some ideas and just start thinking, well, I wonder where it's going to end up. So 20 minutes. Most objects that are near Earth objects will be cleared from Earth's orbit over a period of about 20 million years. So when they say potentially hazardous asteroid, that's what they're talking about. It's not really what most people think of as hazardous. So you can read that here. Now, anything else I need to explain? The observations. Removed objects list, I explained that. This was, oh yes, so go to the JPL page that I was at. And so if you go and look further up this page, remember you can get to it from my search for the object, then you get, as well as the orbit, you've got to click to see the orbit. You go to this page and then you click your orbit view, and you've got to click show, and you can show the orbit. So if you go down, you see all these techy numbers. There's only one really that it's got the Earth MOID, which is minimum orbit intersection distance, which is a techy name. That is what I was talking about about how close it gets to Earth's orbit. So, not to Earth, but to Earth's orbit. So then, if that's within a certain amount, then it counts as a near Earth object. So now, take that number, and remember to include the decimal point. So 0.04, then, so it looks like a tiny number, but remember that 1 AU is 93 million kilometers, so it's actually a big number, even 0.047. So you just write in Google 0.047 AU in kilometers, and it'll tell you that it's over 7 million kilometers. So that's another useful thing you can see on that page. And so I think I've shown you everything. I explain here about potentially hazard objects, but various other things I explain on the page. So if you want to find out a bit more about what potentially has, how it's defined, then click there, and various other things you can read. But the main thing, if you just come here, if you see warning, well, now that I've explained the Sentry table, you can just go to the techy Sentry table and look at the numbers and see if the top one is a 0, then it means it's no hazard. And you can click on it, and if you don't find it there, you can look for it in the removed list. But my page just shows the same things in a much easier to understand way. And I don't think astronomers, so I understand how astronomers think, because I was trained as a scientist myself, as a mathematician myself. And for me, those numbers look very clear. You know, if it weren't that I spend my days every day explaining these things to people, I wouldn't understand. I would be in the same situation. Let's go and find the right page. I would look at this and say, not the removed objects, the other one. Yeah, I'm not there, and there. I look at that and say, well, that's obvious what that means. Why is anyone confused by it? But I fully understand. So I see both sides, as it were, because of helping the people who don't understand numbers in the way that mathematicians and astronomers do. So I can understand why a lot of you just go and look at that page, and you just many people will just say, well, I've never been good at maths, and just click away, and they won't go any further than that. And or they might go and look at this and say, well, look, that's there's this thing I was looking for, and it's in the list, and so they'll be scared if it hasn't been removed. So, but I don't think many people use this. Many of the people that it's just geeks really who use this. I don't think the journalists use it either. I don't think most journalists would be able to understand this either. And so it really helps to. So I said I've tried saying it. I tried saying an email, but I just didn't get any response. And just try to raise awareness. Maybe if any of you have anything to do with it, you watch this video, maybe this helps you to understand why. If any of you read that email, I don't know if any of you read that email, or if any, just very simple change. Change that number 0 to the word no hazard, or change to word normal if it says 1, or just have a tick box if you like to have numbers, which of course mathematicians like, and just have a tick box somewhere, or if you'd like to show legends, say show numbers, to turn it back into numbers, and then have something a bit less numerical, and at the top of the page say that the highest alert level, if any, is no hazard. So just one sentence somewhere here, highest alert level is no hazard, and then just no hazard in that column. And then if journalists who aren't trained in maths visit that page, it'll be absolutely obvious to them what it means. And so I think they should change that, but it's hard to really explain this to people who don't spend all their day helping scared people and panicking people. And if you are getting loads and loads of messages from panicking scared people, you'll get much less if you make that simple change on that page. It is in my belief. Anyway, so and probably much less of these clickbait headlines, because people will then go to that page and they say, well, that headline was wrong. And so the journalists hopefully will stop running them. My personal view. Anyway, I hope this helps some of you to be less scared about these completely incorrect, false warnings and there was no risk. I'll put the link to my debunk of the asteroid that is scaring people right now in the video description, and a link to the pages that I've got open at the moment. So you can go and visit the main one is this one. You can get to all the others from it.